Almost everything you were taught about Jupiter is wrong. Not slightly wrong, not outdated. Fundamentally, categorically wrong. Jupiter is not a gas planet. It never was. Beneath those iconic swirling clouds lies something far stranger. A world of liquid metal, electrical currents, and a core so bizarre that our best computer simulations still cannot explain how it exists. For most of human history, we stared at Jupiter through telescopes and saw clouds. Beautiful, enormous, endlessly moving clouds. And we assumed the clouds were the planet. They're not even close. This is what Jupiter actually is. Before we go inside Jupiter, it helps to understand what we're dealing with in terms of scale. Jupiter is heavier than every other planet in the solar system combined. It contains enough internal volume to fit 1,000 Earths. If Earth were the size of grape, Jupiter would be a basketball. How something this large exists is a question science has not fully resolved. The most widely accepted theory is that Jupiter began as a massive rocky core, formed the same way Earth did, from debris colliding and accumulating in the early solar system. But this core grew so large that its gravitational field began pulling in the enormous clouds of hydrogen and helium gas that surrounded the young sun. It kept pulling for billions of years, until it became what we see today. Under this theory, Jupiter has a dense, solid core at its center, the original rocky seed around which everything else accumulated. There's an alternative theory, that Jupiter never had a rocky origin at all, that it began as an enormous, free, floating cloud of gas that collapsed under its own gravity, the same process that forms stars, just with insufficient mass to ignite. Under this model, Jupiter would have no true core, just layer upon layer of increasingly compressed gas all the way to the center. For a long time, nobody knew which theory was correct. As it turns out, both were wrong. The first real breakthrough in understanding what Jupiter is made of came not from a planned experiment, but from a collision. In July 1995, a comet struck Jupiter. This is not a regular occurrence. Scientists estimate an impact of this scale happens roughly once every 6,000 years. We happen to be alive for this one, and we happen to have the technology to watch every second of it. The comet was called Shoemaker-Levy 9. By the time astronomers located it, Jupiter's gravity had already torn it into approximately 21 separate fragments, the largest still around 2 kilometers across. These fragments were traveling at 216,000 kilometers per hour. There was one problem. The pieces were going to hit Jupiter on its far side, completely out of view from Earth. The impact of the century was going to happen where we couldn't see it. Except that at the exact same moment this once-in-6,000 years event was unfolding, NASA had a spacecraft on its final approach to Jupiter. The Galileo probe, launched in 1989 and named after the first astronomer to study the planet through a telescope, had a direct line of sight to the impact zone. What Galileo recorded was 21 separate collisions over 6 days. The largest fragment alone released energy equivalent to 300 million atomic bombs, the largest explosion ever captured on camera. As Jupiter rotated, the Hubble Space Telescope photographed the aftermath from Earth's side. Enormous black scars in the cloud layer, debris plumes thousands of kilometers high that lingered for months. And then Galileo flew directly through that ejected material. The interior of Jupiter, blasted into space by the impact, was collected and analyzed in real time. The most unexpected finding: water. Enormous quantities of water inside Jupiter, far more than any existing model had predicted. That discovery launched the next phase of the investigation, a new mission designed specifically to uncover what Jupiter truly is from the inside out. It was called Juno. It launched in 2011 and arrived in 2016. What it found rewrote the textbooks. The clouds of Jupiter, the swirling bands and storms that have captivated observers for 4 centuries, are real. But they are not Jupiter. They are a shell. A relatively thin atmospheric layer, approximately 50 kilometers deep, sitting on top of something almost incomprehensibly different below. In the upper cloud layer, temperatures drop below -100 degrees Celsius. Water ice crystals interact with ammonia, which acts as a natural antifreeze, allowing liquid water to persist at temperatures where it would otherwise freeze solid. Where water droplets collide with ice crystals, the clouds become electrically charged, producing lightning storms that dwarf anything on Earth in scale and intensity. The slushy mixture of water and ammonia eventually clumps into hailstones that fall into the lower atmosphere, melt into rain, evaporate, and rise again. A continuous cycle of precipitation that drives the storms visible from space. Those storms run deep. The jets of superheated gas that feed the surface tempests extend hundreds of kilometers down into the atmosphere. The Great Red Spot is the most extreme expression of this. It is not simply a wide storm. It is a towering one. Thousands of kilometers across and hundreds of kilometers deep, it reaches higher into the atmosphere than any other cloud formation on Jupiter. At that altitude, it absorbs additional ultraviolet radiation from the sun, which reacts with chemical compounds in the storm system and produces the distinctive deep red coloration that has persisted for at least 400 years of continuous observation. Imagine a storm 10 times taller than Mount Everest and 10 times deeper than Earth's ocean. The Great Red Spot is larger than that. And all of this, every cloud, every storm, every lightning bolt, is just the surface. The first 50 kilometers of a planet that extends 70,000 kilometers to its center. Below the cloud layer, everything changes. As depth increases, so does pressure, and pressure generates heat. Jupiter's mass is so immense that its own gravity is continuously compressing everything inside it, squeezing the material tighter and tighter the deeper you go. The temperature climbs, the density climbs, and the behavior of matter begins to deviate from anything we encounter in daily experience. Hydrogen is the dominant element inside Jupiter, the lightest element in the universe, and the only one light enough to remain suspended in Jupiter's gravitational field rather than sinking to the core. Every heavier element has already been pulled downward. At approximately 1,000 kilometers below the cloud layer, the pressure becomes sufficient to compress hydrogen gas into a liquid state. Not through cooling. On Earth, we liquefy hydrogen by dropping its temperature to around minus 250 degrees Celsius. Inside Jupiter, the opposite mechanism is at work. The pressure is so extreme that it raises hydrogen's boiling point high enough for it to remain liquid at temperatures exceeding 1,000 degrees. What exists at this depth is an ocean. The largest ocean in the solar system. A vast body of liquid hydrogen approximately 20,000 kilometers deep, 2,000 times the depth of Earth's deepest ocean. This is the true surface of Jupiter, not the clouds. A churning, superheated ocean of liquid hydrogen with no shore, no floor visible from above, and no analog anywhere else in the known solar system. Jupiter is not a gas planet. It is a liquid planet, and it gets stranger still. At the base of the liquid hydrogen ocean, roughly 20,000 kilometers below the clouds, the pressure crosses a threshold that produces something that should not exist. Under millions of times the atmospheric pressure of Earth's surface, at temperatures approaching 10,000 degrees Celsius, hydrogen undergoes a transformation into what is called metallic hydrogen. This is not hydrogen turning solid. It remains liquid. But under this extreme compression, the electrons that normally orbit individual hydrogen atoms are stripped free entirely. They detach and flow through the liquid independently, the way electrons flow through copper wire. The liquid becomes electrically conductive. It becomes, in the most literal sense, a liquid metal. This layer of metallic hydrogen extends approximately 40,000 kilometers deep and is responsible for generating Jupiter's magnetic field, the most powerful planetary magnetic field in the solar system, 14 times stronger than Earth's. And at the very center of all of this, beneath the gas, beneath the liquid hydrogen, beneath the metallic hydrogen, lies the core. Except the core is not what anyone expected. For decades, the prevailing model assumed a compact, clearly defined ball of rock and iron at Jupiter's center, roughly the size of Earth, dense, solid, and distinct from the metallic hydrogen surrounding it. What Juno's data revealed was something far more unsettling. The core is not compact. It is not clearly defined. It is diffuse, a sprawling, blurred region spanning roughly half of Jupiter's total radius, in which liquid rock, liquid metal, and compressed hydrogen intermix with no clear boundary between any of them. Scientists have called it a fuzzy core, a dense soup of mixed states of matter with no hard edges and no clean transitions. We do not know how this happened. Computer simulations run to test the leading theory that a rocky planet roughly 10 times the mass of Earth collided with young Jupiter and shattered its original solid core, scattering it throughout the interior, consistently produced the same result. The fuzzy core forms from the collision. But then, in every simulation, it gradually re-solidifies and compacts back into a defined ball. The simulations cannot reproduce a fuzzy core that stays fuzzy. Jupiter's core should not exist in its current form, and we have no complete explanation for why it does. So here is what Jupiter actually is. A thin shell of swirling gas and cloud, 50 kilometers deep, concealing a 20,000-kilometer ocean of superheated liquid hydrogen. Below that, 40,000 kilometers of electrically conductive liquid metal generating a magnetic field that dwarfs anything else in the solar system. And at the center, a diffuse, poorly understood core of mixed liquid rock and metal that our most sophisticated simulations cannot explain and our best theories cannot fully account for. Jupiter is not a gas planet. It is not a liquid planet in any simple sense. It is a layered, pressurized, electrically alive world unlike anything else we have found. And we still do not know how it was made. For all the spacecraft we have sent, Pioneer, Voyager, Galileo, Juno, for all the data collected and all the models built, the most fundamental question about the largest planet in our solar system remains unanswered. How does something like this come to exist? That question is what makes Jupiter the most compelling object in the solar system to study. Not because it is large, not because it is beautiful, but because it is sitting there in plain sight, visible to the naked eye on any clear night, and we still do not fully understand what it is. The investigation is not over. It has barely begun. If you want to go deeper into what we know about the outer solar system, Saturn, the ice giants, what lies beyond, those videos are on this channel. Subscribe to follow where the science leads next.